Hi and welcome. In this video I'm going to correct a mistake that I had originally made while solving this problem, which a student and a father of that student had caught with his son while solving it, which is exciting to me because I'm happy to push the thinking of my students and also push the thinking of myself, right? Clearly this problem is difficult for me if I made a mistake, and I'm happy to share the correct solution, which they definitely found, and I realize is correct after reflecting upon it. So here we go. We have a rocket ship, and it's going, let's say, in this direction, and also it's going to then come back to where it started in terms of this cargo ship line that's going in this direction. So it says right here, a pilot in the rocket ship starts at the back of a line of cargo vessels and rides to the front of the line. Then the rocket ship turns around and rides to the back of the line of cargo vessels. So it's going from the back of the line to the front and then turning around and going to the back of the line. And later in this problem it says that if this pilot travels at 5 times the speed of the cargo vessels and the line of the cargo vessels is 500 kilometers long, how far do the cargo vessels move by the time the rocket ship gets to the back of the line? So we want to know how far do these cargo vessels go by the time the rocket ship makes this lap. And we know that this line of vessels is 500 kilometers long. And we know that the velocity of the rocket ship, I'll write as v of r, equals 5 times the velocity of the cargo vessels, which is not much information, and I do like this problem because we can use this little bit of information, the distance and this rate, to figure out the answer to this question. So what's happening in the first part of the rocket ship's travels? Well, we know it's going to take some amount of time, we'll call it time A, and then on the return it's going to take a different amount of time, time B. And if you want to think about why it's going to be different, well, the rocket ship is traveling at a constant velocity, right? But here it's traveling with the cargo ships. So in a sense it's going to be slower. We have to take away the velocity of the cargo ships. And then when it turns around, it's traveling against the cargo ships. So it's almost in a sense traveling even faster because the cargo ships are moving against it in a different direction. And we can model that with equations. So we have the velocity of the rocket ship as 5 vc times the amount of time it takes to reach the front of the line, and that's the distance the rocket ship travels in its first part of its journey. Well, what does that equal? That is going to equal the distance that the cargo ships are traveling, so their velocity times that time, and the 500 kilometers that the line is actually stretching. So now we can subtract this term from both sides, and now what we get is 4 vc times the time, so that equals 500 kilometers. Well, now we've got to think about what happens on the way back. Well, on the way back, the rocket ship it's still going to travel at the same rate, right? 5 vc times the different time now, time of B. So that's the rocket ship traveling. Well, that we have to think about the fact that we're adding on the velocity of the cargo ships now because they're traveling in opposite directions, and that is going to be equal to 500 kilometers. And actually, as the father of the student who had emailed me about this problem, we could even think about this as, let me write this I guess up here. We can think about this as 5 vc TB equals to 500 kilometers minus the velocity of the cargo ships during that time period, right? So their distance. So we're taking away that distance because they are traveling in opposite directions. Anyway, so we have this, and now we get this, we combine these two, we get 6, right? The velocity is increasing on the rocket ship because relative to the cargo ships, they're moving in opposite directions, and this equals 500 kilometers. And we can simplify this. We can think of this as 250 over 3, or we can think of this as 83 1/3. So now we're almost done here. I should just go back. We have this, and this we can simplify. Right? I want to divide both sides by 4, and I'll get the velocity times TA will equal 125, and this is in kilometers. And here, this is also in kilometers. Okay, so what does all this mean? Well, the total distance that the cargo ships will have to travel is going to be the sum of these two quantities right here. We have to add 125 kilometers plus 83 and a third kilometers, right? We have to add those two up. And what do we get when we do that? Well, when we add up those two, we get a different number than I got before, which is, well, how do we do this? It's 208 and 1/3, or 0.3, I was going to write there, 1/3 kilometers. And that is how far the cargo ships will travel. And if we're still unsure about why we're adding these two quantities, because I did get some other emails about that as well, is that what this right here is the velocity of the cargo ships times the time of B. What does that mean? Well, we know that distance, the formula we're using here is that distance equals rate times time. Rate can be, you can think of rate as a velocity. So this is velocity times time, or rate times time, of the cargo ship. So that's the distance of the cargo ship over time B, right? Over this time right here. That is distance. The distance of the cargo ship over time B is equal to 83 and a third kilometers. Well, on the way there, the distance, this is the distance right here, distance equals velocity of the cargo ships times this time period, right? That's this distance, V of C times T of A. So the velocity of the cargo ships for the first time period, time A, that equals 125 kilometers, and when we multiply these two, that we're saying that equals distance. So this is the distance of the cargo ships on the first half of the rocket ship's lap. So we just add these two up because it represents the two distances that the rocket ship is traveling over these two time periods. Anyway, yeah, so that's how we do it. 208 and a third kilometers.